In this first video of our two-part series on oxidation-reduction reactions, we are going to learn about oxygen exchange in oxidation-reduction reactions. In a chemical reaction, oxidation is oxygen gain and reduction is oxygen loss. First, let's look at oxidation. A good example of oxidation is a combustion reaction. Hydrogen is a clean fuel that works by combination reaction with oxygen. Energy is released as bonds are formed, and this energy can be used to power cars or appliances. Oxygen also combines with metals. When oxygen reacts with iron, the iron is readily oxidized. Do you know the common name for Fe2O3? Maybe try thinking about what happens to iron metal after it is exposed to air for a long time. You probably got it. Fe2O3 is rust. This is why things made of iron are often coated with other metals, such as zinc, in a process known as galvanization. Of course, zinc can still react with oxygen to make zinc oxide. In fact, it reacts so quickly that the iron galvanized with zinc cannot oxidize because it is coated with a protective layer of zinc oxide. You can make this reaction go even faster by applying heat. The heat provides some of the energy required to break bonds before new bonds can form, the activation energy. Hemoglobin in blood carries oxygen around the body by oxygen exchange reactions. 4 iron 2+ ions sit in the middle of a porphyrin ring. When oxygen binds, the iron 2+ reversibly oxidizes. The negatively charged oxygen is called a superoxide. When it gets to where it is needed in the body, it is released and the ion is reduced back to iron 2+. Now let's look at reduction. Remember, reduction is oxygen loss. Some oxides, when heated, release oxygen and are reduced. Back in the 17th century, people believed that heating a substance would always yield its pure elements. And sure, pure oxygen was indeed first produced by reducing mercury oxide. But what wasn't known at the time was that heating could cause either reduction or oxidation. It is very important that we are able to make metal oxides lose oxygen as pure metals that result from these processes have unique properties that are useful for industry. As an example, take a look into the blast furnace. In here, we can use coke to reduce iron ore, iron oxide, to iron metal. Don't forget, the coke used in a blast furnace is carbon coke, like coal, not a fizzy drink. Usually, the furnace is not hot enough for the coke to react directly with the iron oxide. Coke reacts with oxygen in the air to form carbon monoxide. Is this an oxidation or a reduction? Pause the video for a moment to work it out. Oxygen is gained by carbon to form carbon monoxide, so this is an oxidation reaction. Did you get that right? So what happens to the carbon monoxide next? It reacts with the iron to release pure iron metal. Simultaneous oxidation and reduction takes place. Iron loses oxygen, it is reduced, but carbon monoxide gains oxygen and forms CO2. It is oxidized. We have talked about oxidation and reduction in this video in terms of gaining and losing oxygen, using examples from industry and nature. Now it is your turn to explore other interesting examples you can find around you.